Hi, my name is Sean Benoit, and this is my project. It's on the projectile velocity, and I'm gonna explain how the projectile velocity acts when it hits a barrier. In this case, it is our fabric, our Kevlar fabric, to see if it can stop the projectile or if the projectile is gonna go right through it. So the first slide is basically going to go over what the instrument is. The instrument is a Doppler radar. So the Doppler radar's main purpose is to track the velocity and also track the trajectory of the projectile. In this case, it was a 6.55 millimeter projectile. So the Kevlar vest is a useful tool that is used in law enforcement every day to protect vital organs and prevent anybody who is shooting at law enforcement officials from hitting any of those major arteries. So that's the main purpose of Kevlar vests. The Doppler radar, in this case, is used to track that velocity, but it's also used in weather patterns, used in sports, and used to measure the speed of like aircraft, everything like that. Once you're able to determine that speed, everything like that, you're able to determine if the projectile is going to be able to make it through the Kevlar or if it's going to hit the Kevlar and then it just drops on the floor. So, like I previously stated, the velocity and power is the most important thing of this experiment. So, an example is a 9 millimeter compared to a 22 millimeter. 22 millimeter is not going to have the same speed or the same power as a 9 millimeter. The 9 millimeter, yes, it is a heavier grain, heavier caliber, but it's also a faster caliber. And the way to penetrate something hard like Kevlar or concrete or anything like that is you don't need power, you need speed. The reason why a lot of these Kevlar vests aren't able to protect vital organs from high round ammunition is because the ammunition just tears right through the Kevlar vest. So this acts as like real life scenarios on how researchers can improve Kevlar with the fabric or adding other synthetic material to prevent higher rated ammunition from penetrating the Kevlar vest. So in this case, not only is forensics able to use it for velocity of a projectile, but they're also able to find the trajectory. They're also able to figure out if there's no physical evidence as far as camera footage or anything like that, they're able to determine if the round was fired in a stationary vehicle or stationary individual, or if it's in a moving vehicle, and they're able to see which angle it was fired from, what kind of power it had, everything like that with the Doppler radar. So the main purpose of validating instruments and methods is to prevent any incorrect information. In this case, it's the Doppler radar. And it is so super important to figure it out because not only is this information going out to the public, it's information that's going to be used in possibly court, or like meteorologists use it. It's going to be out for the public. They're going to be wondering when is weather supposed to hit or anything like that. That's why it's important to validate instruments. It's important to audit the instruments by month or every other month depending on the manufacturer settings. And by validating these these equipment allows for this research to be used for decades until more research comes out about it. And it also prevents any miscarriages of justice because the more accurate results you have, the more it gives a fairness to both the prosecution and defense attorney to try to argue that it wasn't. But in reality, it isn't correct. But once you're able to figure out that you have validated the data not once but twice. You have calibrated the machine whenever it needs to. There's no issues with it. It's under proper inspection. That's the purpose of validating the results. So the Doppler radar is, like I previously stated, is an instrument that determines the velocity and direction of an object. In this case, it's to determine a high velocity projectile impact it has on ballistic fabric. So the fabric in this case is Kevlar. So the projectile they used was a 6.5 millimeter projectile, and it has a mass of 1.18 grams. It's shot out of a pneumatic gun, and the velocity was measured with the 10.525 gigahertz Doppler radar. But one of the problems that I understood in this way was they had the radar 12 centimeters underneath the intended target, but also 3 centimeters in front of the intended target. So they have to use different methods to determine if it was going to still hit at the same velocity, if the velocity is still correct, or if there's a huge displacement. So the first thing they used was the empirical mode decomposition. So in this case, it's to test, it's a time series in the sets of IMFs, and it must satisfy two conditions. The number of extreme and zero crossings must either be equal or differ at most by 1. And then second, at any point, the mean of the envelope defined by the local maxima and the envelope defined by the local minima is 0. Meaning you can't have more than one in as far as like displacement. The envelope cannot be one high, or in this case it won't never be one lower than the minimum, but it helps determine the frequency level of the projectile. The next one that they use is called the parallax error correction. So this is the second step. This second step is the most mathematical, and it's able to determine the displacement of the projectile. So in this case, they had the intended target as 0.928. The variation was about 0 to 1.2%, and it missed its intended target by 0.011. So the impact was about 0.939. So this is all in millimeters. So it has that discrepancy a little bit, but it was pretty much on spot. So the validating of this experiment was not only done by the Doppler, but also done by high-speed cameras. The testing was done with the Doppler radar, but once they were to figured out the velocity they got was then used to determine if it was correct from the high-speed cameras. So the high-speed cameras was able to confirm the validation of this experiment, and it satisfied both the first and second step, thus allowing us to determine the correct projectile velocity and correct projectile displacement. And then, was the testing thorough? From what I read, the testing was very thorough. It was informational, and it had given me more insight on how projectiles are calculated as far as the velocity with different instruments. Like I said, overall expectations, I was impressed. I would add a little bit more projectiles to this case, because not every projectile is going to be 0.65 or 6.5 millimeters. It's going to be larger, like a 7.62, or larger than that, 5.56, 7.62, everything like that. So this is my reference. This was my only reference. This was taken off of the GCU library, and this had helped give me great information on machines, equipment, and how the Doppler was used.